Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
Da 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 da.
This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And I have a regular with me in the studio, Ron Cullen. Good evening, Ron.
Good evening, Justin.
How would you go?
Oh, I'm going very well, thank you.
Excellent, yeah. Excellent. And I notice I do have to point out the what you're actually wearing.
Yes. Yeah. Come on, Queensland. Yeah.
And it's decided tonight, isn't it?
It is, yeah. Yeah, decider.
Okay. So for our Queenslander and New South Wales viewers, may the best team win. I've got Ron in the studio. Ron has been doing some fascinating experiments with what we call Trombe Walls. So you might want to tell us what a Trombe Wall is.
Right. Trombe Wall is a very ancient piece of technology. I think it's been used for hundreds of years. And it's just a way of passively heating a wall or an object and being able to use that heat inside a building, or just to sort of get a bit of warmth into a house or something like that, passively, without going through big expense or anything like that.
And huge air conditioners.
Yes. And I've seen a few ideas on YouTube and stuff over the last little while, and decided I was going to give it a try myself. Okay. But just resources, tools, and everything over. It's sort of time. It's been a bit of an ongoing project. And something that's just recently happened at home, we've decided to get our windows upgraded, so we had an abundance of glass and bits and pieces. So it sort of spurred me on to get this project underway again.
Okay. And you had the windows replaced with
double glazed windows, and that was the other reason for getting this thing going, because the double glazed windows being such good insulators, any warmth that we can get into the house during winter is going to be held in a lot better. So
with that change to double glazing, are you seeing that you're using a lot less energy to heat things and all of that?
Yes, yeah. It was put in just as winter was finishing, so next winter will be a better judge of it all. But we've just noticed a big difference in like we rarely use a heat pump now. Just the passive solar heating of the sun coming through the window warms the place up enough. And it's just a really stable temperature.
Fantastic.
And the idea with these little miniature Trombe Walls is when we're getting the really cold temperatures in winter, as long as we've got clear sunny days and we get a bit of sun coming in, it's just going to add to the solar heating, the passive sun shining in the windows, to just heating up a bit of air with these devices.
Okay, fantastic. Fantastic. Now, which way do you want to go? Do you want to go to the pictures, or do you want to go to the device?
We probably could start with the picture, and then we'll have a look at the device shortly.
I'll just get the device up on the big screen. So, now let's just make sure that's okay.
Yeah, that's all right, just like that.
Cool.
Yeah.
What are we looking at here?
Right, so yes, this picture here shows you our lounge room window, which is facing east, and the new double glazed windows that have been installed. And my little Trombe wall is sitting over on the right hand side in the bottom right corner there, just propped up against the gate. Now, the original designs that I saw a while ago, they all sat outside and they channeled the heat inside, but that's a little bit logistically too hard for me to do. I don't want to drill holes in bricks or anything like that, and I don't have the skills to do that, wouldn't be able to do it properly. So that was another thing that stalled me for a while, so I sort of kept thinking about it a bit, and we'll have a look a little bit further down. Now there's the same Trombe wall. We could just call it a beer can heater, because it's made out of beer cans inside that case. The silver is some insulating material. It's the silver foil they wrap around houses. And I thought I'd just experiment by putting that on there, just to sort of, because it gets quite warm, and I didn't want the wood frame to get too hot. So I don't know whether it's going to work or not, but I just gave it a try.
Down to this one?
Yeah, so on the particular day, it was perfect conditions. The sun, there wasn't a cloud in the sky, but the air temperature was around about 10 degrees, and after about 30 minutes, that was the temperature that I was getting on the cans. That's shining it through the glass that's on the front. And 52 degrees, so it was warming up.
5 times that input temperature.
And then after about an hour and a half, it was just kept warming up. That's the highest temperature that I got. Sitting in the top.
79.3.
Yeah, 79 degrees. So I thought that's quite warm. And one thing I noticed when I went to take that photo, as I got down to eye level of the device itself, I could see the actual heat coming out of that hole and just like shimmering in the air, because it was still, the air temperature at that point could have been about 13 or 14 degrees Celsius. And you could just see this column of shimmering heat coming out of the back of it.
Nice. You would have been enthused about this. It's all coming together.
So this was a little experiment I tried about a week or so later. Now you can see in the reflection of the glass there's actually cloud. There was scattered cloud on that day. So this is not the same day. The sun wasn't as intense as what it was the day before. And I thought, or the week before, I thought what I might try is just sit it on the window ledge. It's not meant to go there, but I thought I've got nothing to lose. I'll just give it a try. And I had actually installed a little fan that's in the right hand side.
This is just this hole there.
It's got a little fan there. Just I don't know whether I need it or anything, but I thought it's all prototype at the moment, so I thought I'd just give it a try.
Cool.
And the next photo shows you it doesn't interfere with the view too much. So it's sort of something that could be left there of a morning to help to assist in warming up the place. In the summer you just take it away and like put it in the garage or something. So it's not a permanent fixture. You can just move it out of the way and put it aside if you wanted to.
Portable heater.
Yeah.
And
you go to the bottom one, and that was the temperature that was coming out of it while it was sitting there. Now that's remarkably less than what we had before. A couple of differences. It wasn't as the sun wasn't as intense because of the cloud. And the other thing too, now we're going through 3 planes of glass, because there's the double glazed window and the glass that's in front of the device, so that could have had some impact on it as well. Definitely.
Now, flip over.
Yeah. Now, these are two north-facing windows that we have, and this device that I've built was to fit inside those windows there. So I'm going to make two of them.
Okay.
So I'm just starting with my prototype one. And if we go to the next photo, you can see it. That's how it's sort of going to sit.
Yeah, okay.
And that was before I painted the cans and before I cut the holes and put the insulation in. That's just to see what it would look like.
Fantastic. Oh, I'm now up.
Okay. And you get a little bit of an idea of how it was built. There weren't really any plans or measurements on the internet, on the YouTube channels that I was looking at, so it was just make it up as you go along.
Yep.
So that was just the idea that I came up with.
Are you checking whether the Bogues cans work better than the Great Northern cans? No, sorry.
There is actually a difference.
Oh.
Yes, yeah.
Oh, okay. That was a joke.
No, there is a difference, and it's not whether they work better or not. Surprising to me, not all cans are exactly the same height.
Oh,
so when I put them all together, I just randomly put them together.
Yep.
And then
ended up with all
yes,
cans.
they didn't all line up at the bottom, for example, or at the top.
Okay.
So I reshuffled them, and in horizontal lines, I made them all the same, so it's level at that point.
Okay.
But when I got right down to the bottom, there was a couple of mixed up ones. I had little tiny gaps, but I don't think it mattered. I'll point out just one thing here.
Oh yeah.
I've chosen to go with the cans filling the space entirely.
Yeah.
I don't think you need to do that. You could leave a little gap in between them if you wanted to.
Okay.
And I've also, and this is something that I've learned, which I'll change on the next one, the width of it, or the depth of it, is just big enough to fit the can. So it's all fairly tight.
Yeah, okay.
So one thing I did find out, when it heated up to 79 degrees, I think a few things expanded a bit. Yeah, the glass was actually starting to bulge out.
Ooh, okay.
So I think my next one, I'm going to leave a bit of tolerance to a little bit of expansion if it needs to.
The expansion coefficient of aluminium is actually pretty impressive, actually.
Oh, right, okay.
Yeah.
So, well, that would explain it.
Well and truly. Yeah. So, we've got to acknowledge Anthony VK7LAG on the stream. So, hello, Anthony.
Okay. Now,
this is cool.
This was a little bit of science that I made up with trying to work out, because all the cans have got holes in the bottom of them, and I didn't want the holes to be too big or too small, and because I was leaving the hole on the top the same size, what I ended up doing was calculating the size of the top hole in square millimetres, and then drilling holes in the bottom of the can to try and get it as close as I could.
Okay.
And the way that I tested it was I put my hand on the bottom of the can, as you in the way that it's shown in the photo, filled it up with water, and then pulled my hand away and then timed how long it took for the water to run out. And then I did exactly the same thing and then turned it upside down, and if I got it right, the time for the water draining through the bottom and the time for it draining out the top through the mouthpiece should have been the same.
Okay.
And I got it to within about half a second of it, so it was close enough.
Cool.
I think that was good enough for a starting spot.
Now, the way that you actually timed that, I think, is worth a mention there.
Yes, it was too hard to do it with a stopwatch, stop and start and everything. So I just had a little GoPro camera on the side recording video. So I record the two video sequences and then just step through it and looking at the start time and the stop time to get it more accurately than clicking a start stopwatch.
I love it. I absolutely love it.
Right.
Very good. Now we actually have a can here. So let's head back to here.
So there's the 3 holes that are drilled in the bottom. So they're 3 10mm holes, which I calculated to be approximately the same size as that area there. Not exactly, but approximately.
Cool.
So, and what I'll do in future ones, I might try bigger holes in the top and the bottom. But there's a bit of a trade-off. If the air flows through it too fast, it won't heat up enough.
Correct.
Right.
It'd be interesting to find out what that effect is. So now sitting next to you, and I'll just go sideways.
And I'll
so
just move over here a bit.
and we'll go up a bit.
So the design is for the fan. It's meant to run from the solar panel, and this is just a photocopy of a solar panel just to show you what it's going to look like.
When you prepared earlier. Yes.
Yeah. And the solar panel is then powers the fan in the back. So
you can see the fan going there.
So this piece of paper is working quite efficiently. Don't look at the battery. No.
I love it. I love it.
So the as the cans heat up and generate all the heat and the hot air coming out the top, the solar panel will obviously work and power the fans to just make it a bit more efficient for the hot air to come out.
Yeah.
Now you might be able to see those marks on the cans here.
Yeah, I did notice those.
And it's, I think that's when it all expanded really hot on that 79 degrees. You can see the
yeah.
And they were just touching the glass, and the glass was bulging a little bit. So I'm going to redesign a little bit, make the tolerances, make the little gaps a bit wider.
Yep.
So I've got a bit more play, and it's not going to put so much pressure on it all.
Okay. Fantastic.
So there you have it.
So this is this is sort of, I suppose you'd describe as supplemental heating.
Yes.
If you like.
Yeah. Passive supplemental heating that doesn't cost anything while it's running.
Correct.
And it's just to put the just a way of putting a little bit more heat into your house.
Yep.
During the day, and then it'll retain it overnight with the double glazed glass and all that. We're talking about in the dead of winter when it's really cold.
Yeah.
So you just don't have to rely on heat pumps and stuff as much. Hopefully, we'll know in 12 months' time.
Okay. I know. Well, this is absolutely fascinating. And the recycling effect and everything that kicks in here, is absolutely fantastic. And the fact that you've recycled the glass as well is a bit of a bonus, really.
Came out of the windows that were being replaced.
I'm fascinated to hear the next part of this story and see how well it actually because this is there's a lot of designs, passive solar designed houses that seems to be the in thing right at the moment. Where they have large windows pointed north and all of that sort of thing, and they have large, large stone or brick walls that are being heated, that then release that heat.
Yes.
So absolutely fascinating. So you're getting it's money for nothing, really. So
heat for nothing.
Correct. So. That is and we've got Warren on streaming as well. We've actually got four people watching. So hello, Warren. That is absolutely fantastic, Ron.
Okay.
And I thank you for coming in and thank you for bringing your prototype in.
It's quite portable.
Well and truly, which is quite good because you've built them for those windows.
Yeah.
So.
When you don't want to use them, you can just put them aside.
Yeah, well and truly. I was thinking you can almost fill those windows with...
then you wouldn't get any light in.
No, that's a good point. Good point. So, thank you very much, Ron.
Yeah,
and good luck with Queensland.
Yeah.
Tonight. May all your dreams come true. Okay. So, fantastic. Thank you very much.
Okay.
We'll just reset the studio. And our Trombe Wall will quietly move out of the studio. That's I thought that was well and truly worth having a bit of a look at what's been going on in that space, because we've been watching this at the ATV nights for a few nights, and seeing it develop. So it's just absolutely fantastic. Now don't forget your prepared one. Oh yes, okay. And
Thank you, Justin.
Fantastic. Thanks, Ron.
Somebody else?
Rex, if he wants to come in, that would be good. So this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And that was Ron Cullen with his Trombe Wall, and I'm fascinated to see how this pans out, because we have a large brick home, and I'm always intrigued by the fact that we have this large red brick wall that is pointed north, and it heats up quite dramatically during summer and releases its heat during the night. And I would dearly love to coat it with beer cans and do a very similar thing, but as Ron said, time and a few other things tends to get in the way. But anyway, we'll see whether Rex wants to come in and give us a bit of an update on the optical side of things. But what I do while that's going on, what I might do is just show you a project that's going on. Just bear with me, because I'll grab the project box. Oh, here comes Rex. So, impromptu. Sorry to put you on the spot there.
Well, you have to ask me questions, because I'm not sure what I can say.
Oh, no. Well, that's fine. You've been doing, and welcome, Rex VK7MO. Rex has been doing over the last week or so, since we had the last presentation.
Yes. Quite
a number of tests with Richard VK7ZBX around different LEDs and real world effects, because the path between yourself and Richard is non-line of sight.
That's right. Yeah.
And so just probably a little bit of a summary about what you've sort of been finding along the way.
Right. Okay, well, what we are trying to understand is whether different wavelengths of LEDs are better or worse for the purposes of
long distance.
Now, the problem is the path we've got between myself and Richard's only 22 kilometres, and in general I think that is a path which relies on what I might call particle scatter.
Okay, yes.
Now, normally you would think that that you would be better off to have a longer wavelength to get through the atmosphere.
Okay. Yep.
And the reason you think that is blue light scatters more, that's why the sky is blue.
Yep.
And the sun or the moon, when they just rise, tend to be reddish in colour. So it favours the red.
Yep.
However, when you do a non-line of sight path, you actually want the scatter from the particles.
Correct.
Yes. So
that's how you get the photons between the two locations.
That's right. It's quite different to a line of sight path. So what I was thinking was we might see a difference between these two wavelengths.
Yep.
And in particular I thought it might be different when there are clouds.
Yep.
Because when there's clouds, you don't need the high scattering, because the clouds causes the reflection.
Yep.
Now, so far, the results are that the best wavelength we've got is 655 nanometers.
Yep.
And when we go to a longer wavelength of 730, it's always about 4 to 6 dB worse.
Worse, okay. So 733 is closer to the infrared, up that end.
That's right. Yeah.
So okay.
Now we can't be sure that theory is going to hold on a very long path, where there'll be a lot more opportunity for scattering of the shorter wavelength.
And I was also thinking longer paths, you're not relying so much on clouds rather than crystalline layers, wouldn't it be?
Yes, it will tend to be cirrus clouds, which are ice crystals.
Higher,
Yeah.
colder. Yeah.
I think the main reason, though, is not the difference between clouds and ice crystals. I think the main difference is that at the moment it's a fairly short path, so we're not getting that much scattering along the path.
Yeah. Okay.
So we really need to be able to do this test regularly over a long path, like from here to Launceston.
Yep.
And we haven't actually got someone who's in an appropriate position to do this without me driving to Launceston, waiting for the right situation. So it's not that easy. So what we've been focusing on...
Sure, we can convince somebody.
Well, you would think so, but it's not
PD.
Well, he doesn't live close to a place where you could do this.
He's actually he's at Riverside, I think, and it's just yeah.
So before we embark on trying to do these longer tests, we're trying to establish which sort of LEDs produce the best answers. Now, we did some tests that were 150 kilometres from Mount Wellington to Launceston, non-line of sight, and we got exceptionally strong signals, like minus 14 dB on the WSJT scale, and we're able to get through in 120 second period, just normal whisper. So there's plenty in reserve.
Definitely.
Now, since then, we've tried, and we did that with the Luxeons, with 60 Luxeons, which is what we did 12 years ago.
Yes, crossbar straight, 288 kilometres.
Now, since then, we've been comparing. Actually, I should bring the device in.
Not sure we can fit it in the studio, but yeah. Oh no, that device. Yes. Sorry, I was thinking of cloud burner.
No, not that cloud burner.
So Rex has just gone to get his. He's got a prototype rig, I suppose you'd call it, just so that he can show the different LED types, and we can put that on the close-up camera. So yeah. So we'll just stand by. And this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. So here we go. Over here.
Best place to put this. Okay. Now this is a test bed.
Ooh, that's all right.
Testing different types of LEDs. And what we do is, we've got two transmitters. This is a modulator. This thing here. And we modulate one at say 1575 hertz. And one at 1475 hertz. And then we can directly measure the signal strength on WSJT with the whisper signal.
That's a very elegant way of doing it, actually.
At the same time.
Correct.
And it works brilliantly. And we've got enough. We've got two modulators. And we've got all of these plugs which we can plug in different combinations to test different combinations of LEDs. And there's a 627 Luxeon, 730 Rebel, 655 Rebel, 660 nanometer Cree, and a 730 nanometer Cree. Now these two are new. We haven't tested them. I only finished them off today, and Larry got them today in the mail.
Wow.
In theory, the Crees have about twice the maximum current rating as the Rebels. Now, compared to the Luxeons, the Rebels only have about half the maximum rating as the Luxeons, but we find we can run them both at about 3 times their maximum rating, and the same current in the Luxeons, and they both asymptote to a peak at about 3 times their maximum rating.
And what's 3 times their maximum rating? What current are we talking about?
Well, the maximum rating is 750 milliamps for the Rebels.
Okay.
And the Luxeons is 1.5 amps.
Okay.
But they both peak at about 1.5 amps average, which is 3 amps peak.
Yeah. Okay.
And that's well above their maximum ratings. And the nice thing is that the Rebels at the same current are about 10 dB better than the Luxeons.
Okay.
Now, of course, the double for nothing is applying, so the actual light is only about 5 dB.
So the power rule, yeah.
Yeah. But that produces 10 dB more signal to noise ratio, which is dramatic.
Well,
Now, given that up to now, we're doing Luxeons with 153 kilometres and plenty to spare, another 10 dB out of the Rebels sounds terrific.
Fantastic.
But before I build another...
Cloud burner?
Not a cloud burner, because the other thing we did is a test of the cloud burner versus the 50 LEDs.
Yep.
And it was about 10 dB worse.
Yeah. Now, the difference between the cloud burner and the just the single lens, so it's these lenses.
Yes.
Is on the cloud burner, it's these lenses behind a Fresnel lens.
Yes.
To try and focus all the energy on the Fresnel lens. So what you're saying is, without the Fresnel lens, you're actually doing better.
Yes. Now, there's 2 possibilities. One is we're not coupling the energy onto the Fresnel lens very efficiently.
Yep. Okay.
And the other is, when you get down to a beam width of about 1 degree, like we do with the cloud burner, it's almost impossible to get it aligned. And now Richard tried fairly hard, but it's sort of difficult whether I'm at my place and I'm saying, yes, that's improved, it got better or it got worse, and he's sort of beaming up and down and sideways.
It's better than saying that cloud that looks like a horse.
Oh, that's right. So we're not sure that we have exhausted the cloud burner, but in practical terms it seems almost impossible to get the cloud burner to perform as well as the LEDs without...
Which is fascinating. I actually find that fascinating.
Yes. Now,
given the amount of work that went into the cloud burner.
That's right. And we did cross Bass Strait with the cloud burner, but
correct.
It just seems like it's going to be far easier.
Well, correct. Because in effect, it's this arrangement expanded. In effect.
Yes.
So yeah.
So, given that we got a 10 dB improvement going to the Rebels, Larry did some research and found out that there are Crees with fairly similar wavelengths, which have a slightly narrower beam width, which should be more gain.
Okay.
8.3 degrees.
And that's these lenses, I
yes.
Yep.
Now the Luxeons are 10 degrees.
Yep.
These are 8.9 degrees, so some of that 10 dB gain is
because of the
narrow beam width.
Yeah.
But they're still the same order of beam width, and in terms of pointing, similar thing to manage. And these are slightly smaller, 8.9 down to 8.3, which still the same order of pointing, I would think, but maybe a slight. But the big advantage of these Crees is their maximum rating goes up from 750 milliamps from the Rebels to 1.5 amps for the the 660s and 1 amp for their 730s.
Okay.
Now, while we found that you could run the Rebels at 3 times their rating, and that's where the peak was. It may be just sales that these people put a higher maximum rating, and the higher maximum rating might be expensive lifetime, and the rebel people might want to sell it on the basis of lifetime, and these people might want it. So what we've got to do is now run some tests on both of these to find out where the power peaks.
Okay.
Unfortunately, this fellow here has a device that measures the power with a J16 Tektronix photometer. So,
which was the bee's knees in its day.
Yes.
I'm not sure it is these days.
So when Richard arrives today, I'm going to get him to take this home, and I'm very anxious to see
how the Crees perform.
Oh,
truly.
Whether it's got double the maximum current rating. If it actually gives double the maximum power,
wow,
that's another 3 dB in power, which is 6 dB.
Yep.
Then we pick up another 16 dB over the Luxeons that we've used in the past.
Wacko.
That's probably a bit optimistic.
But we expect it to be better. Just how much better is the question.
I actually expect it to be the same. I reckon that the difference is the salespeople.
Is marketing.
Yes.
Okay.
I just think all these companies are competing each other, and they will...
Correct.
Admittedly, the Rebels are much more efficient than the Luxeons, but the Luxeons are 12 years old.
Correct, and they don't produce Luxeons anymore. So
they obviously think Rebels are better.
Yep.
I will be very excited if we do get 6 dB, and in which case the next one I build will be Crees. But if they're no better, I'll go with these.
Yeah.
But there's exciting things.
I know, well and truly. This is fantastic. Well, I look forward to the next report. I open my email in the morning, and I find an email from Rex, and I read through it, and I go, okay, so we know that much more.
Yes.
So it's very exciting. That's fantastic, Rex.
Yes, you wouldn't have had an email for the last couple of days because I've had to get this thing back
from
Richard. But he should have it again tonight.
Okay.
Whether he gets here in time to get home in time to do anything tonight, I mean, I'm very keen that he does, but that's another question.
Richard's got a life as well, so...
Are people allowed to have a life? I didn't think that was permitted.
Thank you very much, Rex.
Okay.
We look forward to the next instalment.
Yeah.
Fantastic. Alright, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. Now, the next bit, which is in a couple of parts, and the final part you'll actually hear on the broadcast this coming Sunday. I was contacted by Richard VK7RO, Romeo Oscar, hello to Harry Throw 86. So hello from a future amateur radio operator. So hello, Harry. And Anthony just comments, you could rent out your equipment to nightclubs to fund future experiments, Rex. I think that's a fantastic idea. That's thinking outside the box. Do any of the emitters have reflectors? Well, they do have little lenses. They don't have reflectors as such, but the lenses totally cover the 180 degrees and grab all of that energy and push it out forwards. So that's how those little lenses work. They're quite intricate lenses, but that's how they work, Anthony. So anyway, now VK7RO. Richard contacted me to say that another Richard, which is VK7RZ, so Romeo Zulu, who's just down the road from Richard at Taroona, was successful in receiving the 17.2 kilohertz signal from SAQ. That's the call sign. The Anderson spelt with multiple S's because it's Sweden, the Anderson transmitter, the mechanical rotary transmitter in Grimeton in Sweden. Now, for those who don't know, and if you're watching this via RF, you'll be able to see some videos that we've got coming up on Grimeton. And in fact, if you put in SAQ Grimeton, you will come up with their wonderful website and a whole lot of videos and all sorts of things on this particular transmitter. This transmitter was made back in, I think, the 1920s or 30s, and it is now a World Heritage area, a World Heritage site. It transmits using a rotary transmitter, which is actually a generator or an alternator. A generator, no, it's a generator that spins at the rate to actually generate the 17.2 or 17.6 kilohertz signal. We are talking audio. It's the high end of the audio band here. The antennas at SAQ are 8 127 metre high towers with 8 2-kilometre long wires on them. So we're talking about phenomenal engineering here. And the video that we're going to show is a bit of a tour of the Grimeton site, but then the second video is the starting up procedure for the SAQ transmitter, which is phenomenal. So that's some of our videos for our RF viewers after this. However, Richard VK7RZ sent through a little bit more information than I'm going to put on the broadcast on Sunday, but absolutely fascinating information. Did you know that on the Mike Oldfield recording of Tubular Bells, and those people who are about my age and probably older will know that piece of music, and if you go onto the internet you can certainly hear it, but Mike Oldfield's recording of Tubular Bells was reputed to have on the recording the 16 kilohertz signal, CW signal, so the Morse code signal from GBR Rugby in the UK. So Richard was absolutely fascinated by this and decided to try and track down a recording so that he could actually see whether he could listen to this 16 kilohertz signal and see whether he could actually see this recording on the spectrum. So he lets me know that he tried a couple of recordings and found that they had obviously filtered out something that high up in the spectrum, but eventually tracked down a CD that was a 1973 date and a later date of 1983, and bought this particular CD and had a listen to Tubular Bells on this particular CD using a spectrum analyzing audio program, and was able to see the 16 kilohertz signal. And what I've got here is here we go, and I'll pull this across to there. Now if we go to here, there we go. Now what's on the screen now, this was sent to me by Richard VK7RZ, and this is the spectrum here, and at this magic mark here is 16.1 kilohertz, and surprise surprise, there is the actual GBR Rugby 16 kilohertz signal, and what Richard was then able to do was pull out that particular segment out of the spectrum, and he was able to then, and we'll come back to here, because he was able to then send me, and he sent me a recording of the GBR Rugby signal, and I'll just put the microphone right there. Anyway, that's the GBR Rugby signal that sits underneath the Tubular Bells recording. Now, the thing is, how did that end up on the recording? And the theory here is that the recording studio was somewhere near Rugby, and because Rugby was putting out this 16 kilohertz signal at a lot of RF power, and the particular audio equipment that was being used in the studio was not filtering that 16 kilohertz area of the audio spectrum. What ended up happening was it ended up on the recording, and fortunately the frequency response of the equipment was such that it remained on the recording. When it was converted to other technologies like cassette tape and a few other things, a lot of that gets the high pass gets all taken out, but there is still fortunately recordings around that include the GBR Rugby 16 kilohertz signal. So I just found that absolutely fascinating, and also there was another story that actually was related to Richard from Greg VK7RZ, and there is also a Tasmanian connection here to Winston Nichols VK7EM. Now Winston relayed this particular story. He published a great piece of work on the undersea cable and telephone facility entitled The Greenhouse, and this is the submarine cable that went from Stanley across to the mainland, and Winston, and this appeared in the RAOTC, so the Radio Old Timers Club of Australia. Several years ago in the RAOTC journal OTN, and it relates to the mid to early 1930s. And Winston relates, in my research I discovered an interesting story. One Saturday evening, a senior technician on duty at the Launceston Telephone Exchange received a call from a telephonist who noted a strange racket on one of the lines. On investigation, the technician found that it was perfect high-speed Morse code on the line to Victoria. He read the messages and found out that they were from a US Navy operator and reported interference to and on the line to its Navy Department office in Hobart. As his investigations continued, he traced the interference to the King Island repeater station at Narracoopa, and it then became clear that the US Navy had several ships in the area. One was a submarine, and its usual frequency was around 17 kilohertz. The vessel's transmissions had found their way onto the cable or the cable station equipment, as one of the voice channels was also 17 kilohertz. At 17 kilohertz. So the American naval officer was quite puzzled as to how his message could possibly be received in this way. So I thought I'd relate that particular story. Absolutely fascinating, and relates to SAQ. The Anderson transmitter was used for submarine communications for quite a while, right into I think the 70s and 80s. When it was decommissioned. So Northwest Cape is very similar, and there is a Russian station which is in the audio spectrum, and a number of other stations which are in the audio spectrum, all still operating, and you can receive them if you have a suitable antenna and equipment. And Richard goes into what he used to receive the SAQ Anderson transmitter in the broadcast piece that will be on Sunday. So thank you to Richard VK7RZ for relating those stories, and also sharing with us how he received the SAQ signal. And I understand Edward Twining, who is also not an amateur, but he also is very interested in receiving NDB and low frequency transmissions. I think he lives in Moona. Also received SAQ on that particular transmission. So we had a couple of stations in Hobart receiving the SAQ. And if you look at the SAQ website, Richard's signal spectrogram is actually on their front page. I think they were pretty chuffed that somebody down in little old VK7 was receiving their signal. So yeah, worth a bit of a look, and you'll hear about it on the broadcast on Sunday. So just to finish off, because we're nearly at an hour, there are a few projects going on that I just thought I'd give you a bit of an update on. The very first one is we were graciously given a couple of the very nice Pelco PTZ cameras. Which are if you've been walking around Hobart, you will have seen these from a variety of places, and they're being replaced right at the moment, and so we are able to get them at the right price, and they have a wonderful zoom range on them, and what we're doing is changing over a couple of the cameras in the studio and also in the club rooms to PTZ cameras. Now, the problem with them is they are run via RS485, which is a serial protocol, a single two-wire bus serial protocol that's used for a lot of control signals. And so what we've done is this is a little Arduino board that has an RS485 shield on it, and there's a little bit of code running in that's courtesy of the Arduino libraries, and what we can do is control the PTZ functions, so pan, tilt and zoom function via in this case some buttons, or we could make it so that they are some commands. So very similar to what we do now with our remote control camera, we'll be able to do the same sort of thing with our new PTZ cameras that we'll be putting in the studio. So that's one project that's going on around the PTZ cameras and update to the equipment in the studio. We'll also be doing that actually in the club room. So when we have a presentation night, there'll be a couple of remotely controlled cameras that we can press into service, which should be fantastic. Now, just another bit of an update on another project, a club project that's going on right at the moment. Because of my place of employ, I have been able to get a bucket load of RF Quiet, so which made power supplies in a variety of formats, and I think we've got 50 or 60 of these, and at least 50 or 60 of these, if not more. What we're doing is coming up with printed circuit boards that will plug into these. That's my little prototype. That will plug into these power supplies, and it'll come out to Anderson connectors. So that's the PCB mount Anderson connectors. If you've seen those, they solder into the PCB, and they come out on the little printed circuit boards, so that you can then plug radio equipment into your switch mode power supplies. Now, these particular switch mode power supplies, 12.2 volts, you can bump that up at 55 amps, so that's a 55 amp one. And then there is a range of these. This is a 750 watt, so this particular power supply, slightly different PCB. We've got a 64-way edge card connector that goes on there, that comes out to another PCB that'll have the Anderson connectors on them. But the 750 watt version, they come in 450 watt and 750 watt versions, exactly the same size. This 750 watt is 12 volts at 62.5 amps. They really pack it into these boxes and force cool it. These are server power supplies. If anybody who is in the IT industry will recognise these, I can tell you now. But that's the other club project that's going on right at the moment. So watch this space. And I thought I'd finish off. My wife and I sponsor a child in Indonesia through World Vision, and you're probably asking, what's this got to do with radio? We got an update about our particular child, but which had a little bit of a promo for something that's going on in South Sudan, and it involves the distribution of radios. And the reason they're distributing radios is they are actually using them as a teaching method in remote and regional areas in South Sudan. So they issue a radio, and they go through lessons very similar to our School of the Air, which is run for remote children out in the outback. Very similar thing going on in South Sudan. It's absolutely fascinating. This you can hang on. All right. So you can see what I'm looking at. That's probably a good thing. You can see here's 14-year-old Isaac, who's just been delivered a radio in northern Uganda. Receives a radio to help him study. Here's and here he is studying his study material, which I assume comes through the post, and listening to the radio whilst he's that's delivering the lessons. So, and I thought this was fascinating. I want to study so hard and be the president of South Sudan in future. I want to bring peace back to our country. So that's pretty good stuff. So I just thought I'd relay that to our listeners. You come across the uses of radio all over the place, and that happens to be a fantastic one. So yeah. Very last thing, for those who are into Robert Sherwood. Now, Robert Sherwood, if you've seen, is known as the reference for transceivers and testing of transceivers. The Sherwood tests are very well respected within the amateur community and also outside the amateur community in the professional fraternity. Robert Sherwood has just released a couple of days ago his HF test results for the IC705. So worth a bit of a look on his Sherwood. Put in Sherwood and IC705 and you will certainly come up with it. He does, most of his comparison is between the 705 and the KX3. And he certain things, quite a lot of things, he absolutely raves about and says it beats the KX3 hands down. Certain things he says that it doesn't, which is interesting. It's fascinating. And I also include in our videos tonight, there is a video that was released a little while ago of a Japanese service person actually pulling apart a 705, so you can actually see how it goes together and how packed it is inside the 705. So that's one of our videos tonight. So yeah. One final thing. I did read, you would have seen in the news just in the last couple of days, the SpaceX mission, which was a manned flight up to the International Space Station. Those four astronauts, 3 of which were American, 1 which was Japanese. They are all amateurs, all licensed amateurs that have just hit the space station. It's Michael Hopkins, who is KF5LJG, Victor Glover, who is KI5BKC, Suchi Noguchi, who is obviously the Japanese astronaut, who is KD5TVP, and Shannon Walker, who is KD5DXB. So they are all up on the International Space Station now. The crew coming back. They'll be up there for the next couple of months. So excellent to see that all of the astronauts that have gone up there are all amateurs, and I'm sure that they'll be doing the school's contacts, RS contacts in the coming weeks and months. So fantastic. So now just check. Harry, Ron might remember talking to me earlier about the foundation exam. Okay, well there you go. Very good, and I hope Harry, you're one of our foundation assessment people in that is coming up in a couple of weeks' time. So we'll see you at the assessment. So if there's any questions, please drop them into the chat channel. I'll just put out a call on R2 just to see whether there's anybody who'd like to make a comment. This is VK7 OTC, the club station for the DATV night. Just putting the call out. If anyone would like to come back with a comment or question, go ahead. Okay, nothing heard. We'll go to our video night. This is VK7 OTC clear. Videos tonight. We've got one from Larry, VK7WLH, which is a fascinating little short one from the BBC in 1969 called Tomorrow's World, which is a voice Morse to typewriter interface. Fascinating little video. How to use your PC sound card to receive VLF radio. So this is the including how to showing the GBR Rugby 16 kilohertz Morse signal on the Tubular Bells recording. Little short video on the World Heritage Area on Grimeton, the SAQ, and then there is a longer video on the actual live stream from a week or so ago, of them starting up the transmitter, and that's just phenomenal. So anyway, we'll get underway. Thank you for our viewers and those people who are watching on our stream. Hope you got something from the stream, and we'll be back next week with our presentation night, which is the 4 sides of a triangle with Graham VK7 Romeo Echo. So that should be an absolutely fascinating presentation. So anyway, we'll get over to our videos. 73, have a great week, and we'll catch you next time. Cheers.